We're now going to take our first look at an angle beyond 90 degrees. This angle is in quadrant 2, so it's between 90 and 180 degrees. It's an obtuse angle. To define the ratios for this obtuse angle, since we only have definitions for acute angles, angles between 0 and 90 degrees, we need to find an associated acute angle. We form a right-angled triangle and we call this angle alpha. Alpha is the angle between the angle we have marked and the x-axis. Alpha is an acute angle, so we know how to define the sine, the cosine and the tangent for this angle. When forming an associated acute angle, we always form it from the angle marked to the x-axis, and this is an important part of the definition that you should remember. If we call this point xy, then clearly from where it is, the x must be negative and the y must be positive. So when we mark the hypotenuse, the adjacent and the opposite onto our triangle, h is positive. H is always positive, as the hypotenuse is always considered just to be a length. O is positive, since it's above the x-axis, and therefore y-coordinates here are positive. But A is considered to be negative, since it's on the negative x-axis. Now to define our ratios, we define the sine of the obtuse angle theta to be equal to the sine of the associated acute angle alpha. And for alpha, the sine is the opposite over the hypotenuse in the triangle that we've formed, and since they are both positive, this will be positive. The cosine of theta is again defined to be the cosine of the associated acute angle. The cosine is the adjacent over the hypotenuse, and A is negative and H positive, and so the ratio is negative. For the tangent of theta, the definition is the same. The tangent of the associated acute angle. This is the opposite over the adjacent, a positive divided by a negative, and therefore this is negative. If we now consider the three trigonometric ratios in quadrant 2, we can see that only the sine is positive, the cosine and the tangent are both negative for angles between 90 and 180 degrees. It's worth trying to understand this and remember this fact now, and then relate it when we see the graphs of